Hi guys, in this video we are going to see how segment tree works. But before that, you can ask me that why segment tree and not parse table. So let me answer that question that why segment tree and not parse table. Because if the queries contain not only the left and right index and you are set to give return some answer like the minimum, but you are also given some queries where you need to update the range. That is, you will be given an index and you will be given a value and you will be set to update the value in that index in the array. So you need to update the array first. You will update the array. Then you need to update the sparse table as well. So doing the every time set when you are given a query to update, it's not efficient at all. But when we are using segment tree, we can do this in BigO of login. That is, for each query, you will be given you can find the minimum in O of login, and also the updates can be done in O of login. So if you are given few queries, you can do it in queue login time. So it's a significant improvement in the time complexity. Now we know that in a segment tree, the queries can be done in BigO of login time. Okay, and we'll see that how can we do that queries. And before that, we need to build the segment tree. So let's see how can we build the segment tree. So let's first take an array 2, 3, 1, 7, 5, 9. This is the first index, this is the zeroth index, and this is the sixth index, the last index or the fifth index. So for each step, what we will do, we'll take the middle index, left plus right by 2, and we'll further divide this array into two subarrays, that is from the left index to the middle index and from the middle plus 1th index to the right index. So for this case, the middle index is 2 and we'll divide it into further two subarrays, that is 2, 3, 1 and 7, 5, 9. Okay, this is the zeroth index, this is the second index, this is third, and this is fifth. For this, the middle index is 1. For this, the middle index is 4. Okay. Further, we'll divide this, it is 2, 3, and this into 1. Further, we'll do similar, it is 7 and 5, and 9 here. Whenever we'll get a single element remaining, we'll stop divided dividing it further. Okay, like 1 and 9. From here, we get our base case, that is, whenever we are getting left equals to right, we'll simply do what will in the segment tree, for the segment tree's index, we'll update it as array of I, that is array of left. Okay, so whenever we are getting left equal to right. That is a single element is remaining. We'll do this step. Okay. Further, we'll divide it 2 and 3, 7 and 5. Okay. So now from here, what we are going to do in the segment tree, whenever we are getting 2 and 3, we'll return the minimum of 2 and 3. That is the minimum of these two subarrays. Okay. So see what we are getting now. For this step, we did left to middle and middle plus 1 to right. That is this and this. And if we take minimum of 2 and 3, we get 2. Okay. For this step, 2, we divided it into this and this. For this, we have a minimum of 2, and for this, we have 1. The minimum is 1 here. Similarly, for here, it will be 5, and we divided it into this and this. So the minimum of this 2 will be 5. This case, we divided the arrays into this and this 1 and 5, and we'll get the minimum as 1. See, for this whole array, we are getting the minimum as 1. And what is the minimum of this array? This 1. So now you can get the idea how a segment tree works. And see, we are getting something like this. That is looking like a tree. That is, for this reason, it is known as a tree. The nodes are nothing but actually a segment, and it looks like a tree as we divide it further. So this is how we are building our segment tree. So let's see what is the time complexity of building a segment tree. So in the first step, the number of operations is 1. It is we are dividing the whole array into 2 subarrays. Here the number of operations is 2. Here the number of operations is 4. So we can see a pattern that for the each step it's power of 2. This first step 2 to the power 0, then 2 to the power 1, then it is 4, 2 to the power 2. Then the next step it will be 8, that is 2 to the power 3. So there is an array of 128 elements. The number of operations will be 1, 2, 4, and 128. So the sum of all these elements will be 257. That is approx 2 into 128. So the time complexity will be O of 2 into n, that is O of n. So the time complexity of building a segment tree is O of n. Okay.